Thanks everyone for coming. My name is Ben Thurgood. I'm a Principal Solutions Architect in the Public Sector team in Sydney. And I'll be talking to you today about a deep dive into object storage. And we're also very fortunate to have with us today Tim Eckersley from New South Wales Health Pathology to talk to us about an innovative solution that they're using to manage access and cost of their storage solutions. Now, I just want to point out before we start that this is a deep dive into object storage, but we're doing it in 30 minutes. So how deep can we really dive in that time? Maybe a little bit more of a plunge than a dive, but I'll try to prioritize what we go deep into, but I will mention a lot of other things as well. So if there's something that you're interested in, you'd like to follow up with, please come and see us afterwards at the booth or speak to your AWS Solutions Architect. So this is what we're going to cover today. I'll do a level set on the basics just to make sure that we're all on the same page. We'll look at new features. I'll go through that quite quickly. As I say, come and speak to us afterwards. We'll look at workflow automation, and this is one of the most powerful features on the AWS S3 and object storage platform. We'll see how you can use that and take advantage of it. We'll look at best practices to optimize performance on S3. We'll look at the S3 API briefly, and I'll talk to you about some new security capabilities on the AWS platform that's going to really help. So first of all, to talk about the storage portfolio. So today I'll be primarily focusing on object storage. And that's S3 and Glacier. But worth mentioning and understanding that it's part of a broader portfolio of capabilities on AWS, including block storage with EBS and Instant Store, file storage with Elastic File Storage, and of course, we wouldn't be able to do anything on the cloud with our data unless we could get it there. So cloud data migration services are really, really important. Probably familiar with the Snowball for being able to move large amounts of data very quickly. The storage gateway for being able to treat our object storage as if it's part of your on-premises capability. AWS Direct Connect for having a private leased line through to AWS. And also to be able to egress data at a lower rate. S3 transfer acceleration, I'm going to go into a little bit today and mention that. And Amazon Kinesis Firehose for streaming data directly into S3. And also wanted to point out today that the database migration service also includes a new feature. I don't know if you went to the talk earlier today on database migration, but database migration service includes a new feature that enables you to treat S3 as a target for your database migrations. Okay, so I feel really privileged to talk to you about S3. It's one of the services that really captivated my imagination when I first started working with the AWS platform as a customer a few years ago. And I think it's one of the most underrated services. And the reason is because we all have heard about the incredible durability, 11 nines of durability, but also its ability to scale massively to support any kind of operational scale we could think of. And it's handling trillions of objects and millions of requests per second regularly. And what this enables us to do is to take advantage of it as a linchpin in our applications and our architectures. And that's what we do. We see it on almost every architecture drawing we've ever done. And it's because we can really rely on it to do a huge range of things and build on it and use it to innovate over. So whether we're protecting and securing our data, we've got a range of services to do that. Ingesting the data, I mentioned a few already. Of course, creating applications that use the data and compute on that data. Allowing access for our users to that data. And delivering that content all around the world in any format we can imagine. Catalog and searching it. And of course, processing and analyzing it. And it's this capability of S3 to be durable and scalable and performant that enables us to build it, to use it as a linchpin in our architectures like this. So, as I said, a bit of level setting. First of all, S3 includes, or the object storage platform includes standard S3, which you're going to use for active data. So data you're accessing really regularly. And at the other end of the spectrum, you've got Amazon Glacier, where you're putting your archive data. In the middle, we've got infrequently accessed. And the difference is primarily around the cost of accessing your data and storing it there. And these services are optimized towards different use cases. So these are the common use cases you'll find for each of the different storage tiers. First of all, static website hosting is very common with S3, and especially in conjunction with CloudFront. Content distribution, Netflix is a great example of that. Many other services similar to that are using S3 to be able to store that content and serve it up. Big data analysis. Health Direct Australia use S3 as part of their big data analytics platform, where they're ingesting large amounts of health data from disparate organisations. They're analysing that data and then they're providing it to the public in a way that they can consume easily to get relevant health information. Now, standard and frequent access has two different scenarios that you'll find it being used in. The first is when you're actually moving it directly to standard infrequently accessed because you know that data doesn't get accessed very often. And that could be backup or disaster recovery, that type of thing. The other scenario, and this is really common, I have a lot of customers asking me about this or using infrequently accessed in this way, is where you have data that's hot at the beginning, it's accessed really often at the beginning, but at some point in its life cycle, that access drops off and it stays off. And Pinterest is a really good example of that, where pins get put onto the platform, people are looking at them quite regularly and they're getting lots and lots of hits, and then very quickly interest drops off and there's this kind of long tail of access. And infrequent access is a really great use case for that. Now, how do you handle that sort of dual use case about when it's hot in the beginning and then it becomes infrequently accessed is what I'll talk to you a bit later about as well. Finally, with Amazon Glacier, as I said, long-term archival digital preservation. Sony DADC stored 1 million hours of video on the Amazon Glacier platform. And we can use it for things like Vault Lock, where we want to attain retention for a certain amount of time. We want to say this data can't be changed or deleted for 7 years or for 10 years or for ever, or whatever that use case is you have. That's a common use case for that. All right, so let's talk about some new features. As I said, I'll go through this quite quickly. So first of all, I mentioned standard and frequently accessed, and a big question I get from my customers is when should I move my data there and what should I move? I've got a whole bucket of data. Some of it gets accessed regularly, some of it doesn't, but how do I handle that? So what we did was we created a feature called S3 Analytics, and that enables you to get visualizations of your data and its access patterns over time. It looks at the age of the data with respect to how long and how often it's being accessed. And you can do that by bucket. You can query a bucket. You can query a prefix. You can query an object tag, which I'll talk a little bit more about soon. And then easily create lifecycle policies based on the recommendations that it gives you in order to set it up so it'll be automatically moved at that given time period. So this is an example of an S3 Analytics, looking at S3 Analytics. So you can see that 2/3 of the data is not being accessed, and only 1/3 of the data is being accessed regularly. And you can go deeper than that and see options where you can see that this sort of analysis of this data over this time period is showing us that a data that's 90 days or older is being recommended to be moved into infrequently accessed. Another question related to this that a lot of customers ask me is how do I handle really large object stores when my buckets are getting really, really large? How do I handle getting an efficient list of that data? And some customers, it's such a problem, they're actually building their own solutions for creating a metadata store and keeping track of all the puts and gets and all of the different changes to their data. So we created S3 Inventory to do that for you. It can give you a daily or weekly snapshot. It sends it in CSV format, and you can ingest it into your own analytics platform, or you can use it in any way you want. It's a eventually consistent look at the data, and so it's really important to check with the head object before you take action on it, but it'll just save you a lot of time, especially with those large data sets. Another one I want to mention is we now have S3 data events, which is CloudTrail events down at the object level. So you can monitor every change that's happening in your buckets at an object level so that you're able to track your users, what they're doing in real time, and be able to take remedial action if necessary, and it'll help with auditing and compliance. Another one to mention is CloudWatch metrics for S3. So now you can, I'm going to skip through this one pretty quickly to show you the actual metrics. So you've got things like first byte latency that you're able to get on your S3 buckets now. Also, organizing your data with object tags. Now this is a really powerful feature that we've been wanting for a very long time, where you can tag an object anytime. So usually when you create an object, you can't change a lot of the metadata with it, but with tags you can. You can have up to 10 tags per object, and this gives you a lot of power with respect to the workflow capabilities of the platform that I'm going to talk to you about next. Okay, finally, Glacier, I just wanted to make sure you were aware that it has some new retrieval tiers. So you're probably aware that already that it can do retrievals in 3 to 5 hours. But some of our customers were in the situation where they're like, in an emergency, I just really want to be able to get that data. So we introduced expedited retrieval, where you can get it in 1 to 5 minutes. There were other customers, though, that said, actually, I don't need it that fast. And is there any option with that? And so we put together bulk retrieval. So this is where you can actually get it over a slower, longer period. And the advantage of either direction in this case is that you're going to pay a little bit extra in order to get it more quickly, or you can pay a little bit less and get it slower, depending on your needs. Okay, so now I would like to talk to you about workflow automation. As I've been saying, extremely powerful feature in the platform. Firstly, data management lifecycle policy. So you can automate your lifecycle policies. And this is about the lifecycle of your data and how you move it between the tiers that I was talking to you about. So you can have rules that will match against a bucket, a prefix, or an object tag, as I said earlier. And you can change those objects tags, as I said. So I'll get into that in a moment. And then you can have a transition rule that says, based on that filter, move those objects into a different tier of storage. And so you could move them from standard to infrequently accessed or to Glacier. They can be combined, and you can also look at older versions as well. So if you turn versioning on, which is the best practice we recommend to make sure that your objects aren't deleted, then you'll be able to use this to clean that up if necessary. Also, so this is an example here of a lifecycle rule. So you've got the prefix being matched, you've got a couple of tags being matched, the transition rules to move to infrequently accessed after 90 days and Glacier after 365 days, and then expiring the data after 10 years and deleting it. So here's an example in code where we're actually looking for a specific tag, and we're looking for a tag that's setting the temperature of the data, and in this case to cold. If the temperature or tag is set to cold, then it's going to transition it to Glacier straight away. Now when I say straight away, it's in the next kind of sweep that the platform goes through, usually within a day or so. And if I now make a call on an object and set that object's tag to the temp tag to cold, then that object's going to get picked up. So as you can see, you could use this in workflow to make changes to how your data is used and decide that this data needs to be moved somewhere else and that type of thing by using these tags. The next one that's related to this, and another really powerful feature, is S3 event notifications. So with S3 event notifications, you can be notified of any event that's happening on a bucket. You can filter by prefix or suffix, and you can look for it'll tell you any put, post, copy, or delete, and you can trigger from that an SNS topic, an SQSQ, or a Lambda function. So here's an example of one where we're filtering against looking for images, looking for JPEG images. So we're looking for a prefix and a suffix. And if there's a put done into the bucket that matches that, we're going to get a message onto a queue, and we're going to be able to take some action on it. So that could be transcoding that image, creating thumbnails for it, or sending it to recognition, to do some facial recognition or whatever it is we have in our pipeline. So again, you can imagine the sorts of workflow you can create without having to have servers, without having to manage the code behind all that. Okay, so now onto some performance tips. So I mentioned earlier that some of the power of S3, apart from the durability, is its scalability. And that's because it's massively horizontally scaled. And if you're going to do high performance, or you want high performance out of your systems, you want to take advantage of that scale. So I'm going to give you a few tips as to how you can do it. If you look into the API for S3 or any of the details into S3, you'll find out about these features. And the first one I want to talk to you about is when you're putting objects, you can take advantage of parallelization by doing a multi-part upload. So you can break your object down into chunks, and you can upload that a chunk at a time, either iteratively or in parallel. So you can take advantage of the threads you have available, the CPUs you have available, or even the machines you have available to distribute that out and ensure you're using all of that network bandwidth. And that's going to increase your aggregate throughput. The other thing that it's going to do, though, is it's going to increase the resiliency of your solution to network failures. Because you can imagine if you've got your whole object and it fails and you have to start again, versus if you've just got a part of the object that fails and that has to start again. So that's a really powerful capability. Another one with uploads that is worth knowing about is transfer acceleration. Now, this is where just by changing the endpoint in your upload, you can take advantage of the 77 edge locations that AWS has available. And instead of transferring it over the internet and dealing with that, whether it's going to be slow or also unreliable, you can actually take advantage of the AWS network. And what it will do is it'll send it to the closest edge location automatically. And then it'll send it to your target bucket via the AWS network. And depending on where you are, it's going to have a stronger effect and a better advantage. So, for example, I have a customer that needed to do this between Sydney and London, and they saw an 80% increase in transfer acceleration. So, if you have those needs, it's definitely worth checking out and being aware of. Another one with downloads, the same thing. So, when you're looking at downloads, again, how can you parallelize it? Now, parallelize it. How can you do that? Well, with a get, you can use a ranged get to specify specific byte ranges in your objects and take chunks of your objects at a time, either iteratively, as I've said, or in parallel, threads, processes, or machines, in order to get that down quickly. Now, I should say, though, that if you are trying to do lots of downloads, you've got an application, for example, that your users are using and they're trying to download content from you, or they're trying to download aspects of the application quickly, it's a really best practice to use S3 in conjunction with CloudFront to ensure those objects are cached at the edge. And we see that as a really common pattern. They sort of go hand in hand with any web hosting that you're doing with S3. Okay, the next thing related to performance is throughput around distribution of key names. Now, I mentioned parallelization. So he's talking about parallelization of a data store. How are we going to manage that? Well, it's done with petitions. So behind the scenes, you're hitting a petition, and the petition is dictated by the key name. So if all of your objects are, for example, sequential, or they're all starting with the same timestamp value, what's going to potentially happen is that they could all hit the same partition. And for all of your gets and all of your ports, they're now getting bottlenecked through a single petition. So what we'd recommend instead is introducing randomness into the beginning of your key names to ensure that that doesn't happen. And you could either do that by calculating a hash whenever you get input, or by using a reverse timestamp. So this is just an example, and you can see it's the same timestamp just reversed, and then now you've got the randomness. All right. So now I'll talk to you about the S3 API, give you a brief introduction to that. It's a REST API, like all of our APIs. So you can use the S3 API with any application programming language you'd like to that suits you. I've just done an example here with curl to just demonstrate that. But most of our customers will probably find some advantages in using one of the SDKs because it's quite convenient. And here's an example of using the Python SDK, which is called Bodo 3. And doing the same thing here, an upload or a download, able to do that really with very little code. And it's managing all of the authentication and everything else for you behind the scenes. One of the other advantages of using an SDK as well is they often have already implemented some of those best practices for performance that I mentioned earlier. And that's the case with Bodo 3. So it's automatically going to do multi-part uploads. It's automatically going to do ranged gets. It's automatically going to take advantage of whatever compute power that you have available to you to make sure that you get it done as quickly as you can. Now, it comes set with a bunch of most reasonable configuration options, but if you want to go deeper than that, you can actually change those configuration options to change the threshold around when it'll break the object apart. You can change how much concurrency it will have and that type of thing. And if you want to go even deeper than that, you can use the SDK to access all aspects of the API, S3 API. For example, here using the ranged get that I mentioned earlier in a while to get that object down. This code example is from the S3 driver project as part of it's an S3 driver for the Open Data Cube that Data61, which a part of CSIRO, created in order to manage really large data sets really easily. So what this enables you to, researchers and scientists to do, is to access large data sets in multidimensional arrays as if they were stored in memory. So this is sort of showing the power of S3. So you'd have that massive scalability and performance and durability behind the scenes, but you're able to access these really large geospatial and Earth observation data sets. And I'll just finally talk a little bit about security. So we all know with AWS, security is job zero. And S3 is no different. It's very compatible with government, and that's because it supports all of the security needs you would have, like encryption at rest and in transit. You can have CloudTrail, as I said earlier, with the data events, monitoring everything that's ever done in your buckets to ensure you're meeting your compliance needs. You can have access control with IAM, bucket policies, and ACLs, and you can have VPC endpoint policies, for example, here, restricting all requests to this particular endpoint, not letting a request come from anywhere else. But with the proliferation of data in the cloud, customers have been asking us for, how are we going to manage all of this data? How do we know what we have stored in the cloud? How do we know where it fits into our organization, how it's classified? I'm sure many of you have struggled with the problem of data classification, especially as the data is growing. And also, do I have personally identifiable information, and where is it? And not only that, based on all that, how is it being accessed by what users when and in what context? And can I set up automatic remediation to ensure that if there's any policy breaches happening, they get fixed as quickly as possible? So Amazon just introduced a new service called Amazon Macy that's going to be able to answer a lot of these questions. Now, it's released in GA. It's not in Sydney yet, but based on your feedback, we're hoping to try to get it here as soon as we can. What it does is it uses natural language processing to understand and categorize your data automatically. Okay, and it'll give you a view of that and be able to understand what data you have where. It'll also use machine learning and unsupervised learning algorithms to set a baseline of activity on all of your data access and give you preemptive alerts if any anomalies are detected. So this is an example of the sort of breakdown you can get to understand what data you have and how old it is and what category does it belong to and its risk level. And you can look at this at different risk levels. And then, as I said, you can set up a whole range of alerts to find out if somebody's done something that's potentially going to put that data at risk. And that's going to be contextual based on the type of data it is. So the higher the alert, if you've got more sensitive data that's more at risk and that type of thing. So that's the first part of our talk today. As I said, I've gone through some new features quite quickly just to make sure you're aware of them. Please come and speak to us or your AWS solutions architect if you've got more questions. We've talked about the power of workflow automation with lifecycle rules. We've talked about and S3 events. We've talked about S3 performance optimization and how to take advantage of parallelization. Shown you the S3 API briefly and introduced you to Amazon Macy, which I'm sure will be a great service for the future.